Hi there, and welcome back to my classroom. In this video, we're going to deal with part 2 of dihybrid crosses, and we're going to have a look at specifically how do we determine the genotype and the phenotype of the P1 generation. Now, just a gentle reminder that dihybrid crosses has got two sets of alleles, not just two alleles, two sets of alleles, and that normal dominance rules will still apply. Although in grade 12 life sciences, most often you're going to get an example of complete dominance. So if you know about complete dominance, this should be okay for you for now. Let's jump right in, and we're going to have a look at an example from Life Science Paper 2, November 2021. Now, I'm not going to worry too much about what questions they were asking. I'm just going to have a look at the information they were given, and that will give you an indication of how they can ask this question. So let's have a look. They say in humans, short fingers and a widow's peak are dominant over long fingers and a continuous hairline. That is why we are highlighting here. So we're going with short fingers and long fingers. That's our one characteristic. And our other characteristic is the widow's peak or the continuous hairline. And they've now told us which ones are dominant and which ones are recessive. Now they're saying a man and a woman, both heterozygous for the two characteristics, plan on having a child. And then they give us the Punnett diagram. Now, the first question that they can ask here is they can ask you, what is the genotype and the phenotype of the parents? And there are two ways of doing it. You can have a look at the Punnett diagram and try to work backwards, but in this case, it's actually going to be easier just to have a look at the information that you were presented with here at the top and trying to determine what the parents are going to look like. Now, what is key here is they say a man and a woman, both heterozygous for the two characteristics. That means that the two parents actually look exactly the same. And if they're heterozygous, that means that the two characteristics, one will be a small letter and the other one will be a capital letter. So let's have a look. That means that if we look at their genotype, that they're going to have a capital F and a small f for the fingers, and they're going to have a capital H and a small h for the hairline. And this will be both of the parents. It is very important here that you make it easy for the examiner to give you marks by making sure there's a distinct difference between your small letter f and your capital letter F. Then next up is the phenotype. And for the phenotype, we now just need to figure out what will show in the parent. And because the parents have got short fingers, that dominant characteristic over there, we can then write short. And remember, not just the word short, short fingers. It's like adding a unit in your answers when you do calculations. And then with the hairline, the widow's peak was dominant. Right. In our next video, we'll come back to this example to have a look at how do we determine the offspring. Our last example comes from Life Science Paper 2, and this will be a June 2022 paper. And they're saying in this one, a tomato plant will have a tall stem, which can be dominant over a short stem, and red fruit, which is dominant over yellow fruit. Again, take my suggestion, highlight the one characteristic, so tall stems and short stems in one color, and then the red fruit and the yellow fruit in a different color, just so you remember what is where and that it's actually two separate characteristics. A farmer crosses a homozygous tall yellow tomato plant with a plant that's heterozygous for both characteristics. So let's have a look at what those parents will look like. Homozygous tall, now remember homozygous means the two characteristics look exactly the same, and if they are tall, it means that they're showing the dominant characteristic. Yellow tomato, and yellow is the recessive characteristic, and if it's showing the recessive characteristic, it means it automatically has to be homozygous. And that's going to be crossed with a plant that's heterozygous for both characteristics. Now, heterozygous means that the two characteristics do not look exactly the same. And again, see how careful I am with my handwriting, making sure that my capital letter T, my capital R look different. I hope that helps. Thank you for visiting the Chaotic Classroom. See you next time.